Analyze the kinetic data provided in the study. The table records the time, T, concentration of the reactant, number 2, natural log of the concentration, ln number 2, and the reciprocal of the concentration, 1/number 2, at regular 100-second intervals. Recall the relationships between concentration functions and reaction order. For a zeroth-order reaction, a plot of concentration versus time is linear, indicating a constant rate of concentration decrease over time. For a first-order reaction, a plot of the natural logarithm of concentration, ln A, versus time is linear. For a second-order reaction, a plot of the reciprocal concentration, 1/A, versus time is linear. Test the data for first-order linearity. Calculate the change in the ln number 2 value over each 100-second interval using the table data from 0 to 100s, minus 1.01, minus 0.693, equals minus 0.317 from 100 to 200s, minus 1.25, minus 1.01, equals minus 0.240 since the rate of change of ln number 2 is not constant over equal time intervals. The reaction is not first order. Test the data for second-order linearity. Calculate the change in the reciprocal concentration, 1/number 2, over each 100-second interval, from 0 to 100s. 2.75 minus 2.00 is equal to plus 0.75 liters/moles from 100 to 200s. 3.50 minus 2.75 is equal to plus 0.75 liters/moles from 200 to 300s. 4.25 minus 3.50 is equal to plus 0.75 liters/moles. Identify the reaction order and consistent rate law. Because the reciprocal concentration, 1/number 2, increases by the same constant amount, 0.75 liters/moles, during every 100-second interval, a plot of 1/number 2 versus time yields a straight line with a constant positive slope equal to the rate constant k. According to the integrated rate laws, this linear relationship is consistent with a second-order reaction. Consequently, the differential rate law takes the form rate equals k, number 2, to the power 2. This identifies option B as the correct choice. The correct answer is option B. Rate equals k, n02 to the power 2.